Welcome to the IIT PAL series of lectures on mathematics. This is a sequence of lectures on the binomial theorem and its applications, and this is lecture 4. In the last several lectures, we have discussed the binomial theorem. We have come up with the statement of the theorem. We have seen several applications of the binomial theorem. And today I am going to focus mostly on problem solving. Right. Now, let us take our first problem that I wanted to do today. So, in this set of problems, there can be a variety of problems for related to the binomial theorem. So, one of the concepts is the numerically greatest term. Now, what do I mean by this? So, think about this. You have got, let us say, x plus y whole power n, and this is equal to x power n plus n choose 1 x power n minus 1 y plus n choose 2 x power n minus 2 y squared plus dot 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 all the way till y power n. Now, which of these n plus 1 terms, there are n plus 1 terms here, just by the way, if you did not think about it too carefully, there are n plus 1 terms here. So, which of these n plus 1 terms is numerically the largest? Okay. So, think about it. Every term is related to the previous term. So, if I call this T 0, T 1, T 2 all the way till T n, right, you can set up a relationship between any term and its previous term. So, for example, T 1 is related to T 0, T 1 by T 0 is equal to N C 1 y by x. Okay. So, it is actually, I will write it as N C 1 by N C 0 y by x. Pick any term, pick the second term and the first term. T 2 by T 1 is equal to N C 2 by N C 1, and the second term is larger by a factor y, smaller by a factor x. Okay. So, this we know. Now, if you look at these ratios T 1 by T 0, then you look at T 2 by T 1, then you look at T 3 by T 2, then what you are going to find is that these ratios will keep changing, will keep moving around, and you will get a maximum to this ratio, right. Beyond a certain point, this ratio is going to start, I am sorry, beyond a certain point, the term is going to become smaller, right. So, this T 1 by T 0 initially might be more than 1, which means if it is more than 1, then T 1 is more than T 0. If this is less than 1, then T 0 is more than T 1, whatever it is. T 2 by T 1, if it is more than 1, then T 2 is greater than T 1, and vice versa, right. So, what you are going to find is that at a certain point, T r plus 1 by T r might suddenly become less than 1, right. If such a thing happens, then T r is greater than T r plus 1, right, and there you declare that T r was the numerically greatest term. So, this ratio is going to change continuously. It is probably going to decrease continuously, monotonically it is going to decrease, or it is going to increase continuously. It is going to be something which moves monotonically in one direction. So, it is not going to keep going up and down, for example. So, let us see, find the numerically greatest term in let us say 2 plus 3 x whole power 9, where x is 3 by 2. Okay. So, what will you do over here? You can imagine this as 2 power 9 plus NC1 times 2 power 8 times 3 x plus NC2 times 2 power 7 times 3 x whole squared plus dot dot dot, right, and then the last term is 3 x whole power 9 NCN. I am just trying to do this the long way, right. There is a shortcut. I mean, if you are willing to memorize, then you can use the shortcut, but let us just see conceptually what is going on over here. So, conceptually speaking, this is the expansion of the entire question, 2 plus 3 x whole power 9. Now, the rth term over here, let us pick the rth term and let us pick the r plus 1th term. All right, and T r plus 1 by T r is going to be what? N is what? 9 over here. Okay. This is how it is going to look like, 3 x by 2 times NCR plus 1 by NCR. Now, n is 9. What does this mean? NCR plus 1 by NCR, factorial 9 by factorial r plus 1 by factorial 8 minus r, that is NC 9 C r plus 1, and 9 C r is factorial 9 by factorial r and factorial 9 minus r. And now things are going to cancel. Okay. Between 9 minus r factorial and 8 minus r factorial, most of the terms of all the terms of 8 minus r factorial will cancel out, and all that will remain is 9 minus r. Okay. And between r factorial and r plus 1 factorial, all the terms of r factorial will cancel out, and all that will remain is r plus 1. So, what you have is okay. You have further been given that x is 3 by 2. So, you can write this as 9 by 4. All right. Now, take a look at this. When r is equal to 0, what is this ratio? T r plus 1 by T r, r is 0. So, this is numerator is 9, denominator is 1. So, this is equal to 9. 9 into 9 by 4 is certainly more than 1, which means that the first term is larger than the 0th term. Okay. then r equal to 1, 8 by 8 in the numerator and 2 in the denominator. So, it is a factor of 8 by 2, which is 4. 4 times 9 by 4 is 9. So, still the second term is 9 times larger than the first term. Okay. So, what happens next? This numerator is decreasing, this denominator is increasing, right. So, slowly the numerator is decreasing as r increases, numerator decreases, denominator increases as r goes up, which means that this entire factor goes down as r increases from 0. So, there will be a point where r will suddenly become less than 1. That term is numerically the greatest, right. After that r will still remain this ratio is still going to remain less than 1, it is going to remain less than 1 after that, because the entire ratio is going to keep decreasing. As r increases, the ratio is going to decrease. Okay. So, we just have to find the point where 9 minus r by r plus 1 times 9 by 4 is less than 1. What is r? Such that 9 minus r by r plus 1 times 9 by 4 is less than 1. And can we work this out? This is much easier to work out. So, you have got 4 r plus 4 greater than 81 minus 9 r, and then put the r's together. So, you have got 13 r on this side and you have got 77 on the other side, which means r must be greater than 77 by 13. What is that? 78 by 13 is 6, right. So, 6 is certainly larger than 77 by 13, correct. So, the sixth term is going to be the first term. So, r equal to 6 is the first term, 6. So, r equal to 6 will satisfy this, r equal to 7 will satisfy this, 8 will satisfy this, 9 will satisfy this, right. We are looking at the first one, the first point where T r plus 1 by T r becomes less than 1. That is the edge at which you have got the numerically greatest term. So, the numerically greatest term is the sixth term in this case. So, you want to check it. If you have this, if you look at the sixth term, what happens? 9 minus 6 is 3 by 7 times 9 by 4. So, here this becomes just less than 1. You have got 27 by 28. Okay. So, you are just less than 1. So, the seventh term is just less than the sixth term. That means, the sixth term was the largest. Okay. One more example. Let us try this. What is the numerically greatest term in 3 minus 5 x whole power 15, where x is equal to 1 by 5. Okay. So, once again T r plus 1 by T r, what is that equal to? That is equal to 15 C r plus 1, 15 C r, and in the numerator. So, the r plus 1th term is larger by a factor of minus 5 x, okay, smaller by a factor of 3. Okay. Any questions so far? It is larger by a factor of minus 5 x, smaller by a factor of 3. This is T r plus 1 by T r. And what is this? How does this evaluate? This is factorial 15 cancels out, right. Then up you have got factorial r, down you have got factorial r plus 1, which means r plus 1 stays in the denominator. Up you have got 15 factorial 15 minus r is in the numerator, right, and in the denominator you have got 14 minus r. So, 15 minus r stays in the numerator. Okay. Now, what happens here? So, let us take the minus out. Now, as r increases, what happens? This ratio is always negative. Okay, this ratio is always negative. Minus 15 minus r by r plus 1. R is going from 0 all the way till 15. So, this ratio is always going to be negative. Okay. Sometimes the term is positive, next term is negative, again the term is positive, again the next term is negative. Positive and negative terms keep alternating. But if you are looking for the numerically greatest one, you are looking for the number, the overall number. So, this minus sign is just thrown in there to confuse you, right. It is just an added gimmick which is confusing you. Ignore the minus sign, do not worry about it, because what you are looking for is numerically which term is the largest. I mean, if I have something like 25 minus 32 plus 43 minus 67, numerically which is largest? 67 is the largest one. Okay. So, plus or minus, it does not matter. So, the minus over here is just thrown in to add a spanner in the works. So, you are just going to get confused over here. Do not be confused, do not worry too much about this minus. Okay. So, if you do not worry about the minus, then as r increases, the numerator keeps going down, the denominator keeps going up. Okay. And then what happens? Then there is going to be a certain point after which this entire ratio is going to become less than 1. So, if you look at r equal to 0, for example, r equal to 0, this is 15, numerator is 15, denominator is 1. So, this entire fraction is 15 times 5x by 3, 5 times 1 by 5 is 1 by 3. So, 15 by 3 is a factor of 5. Okay. So, you start with 5. So, the first term is 5 times larger than the 0th term, okay. And then slowly you step the value of r, there is going to be a r at which T r plus 1 is going to become smaller than T r, which means 15 minus r by r plus 1 times 5x by 3, 5x by 3 is really 1 by 3 is less than 1. And what is r in that case, right, that is what you are looking at. So, you solve this, 15 minus r is less than 3 r plus 3, and then move things around, 4 r must be greater than 12, which means r must be greater than 3. So, r equal to 4, when r is equal to 3, you will still have T r plus 1 is greater than T r, but when r is equal to 4, T r plus 1 is no longer going to be greater than T r. Okay, let us check. When r is equal to 3, what happens? 12, 15 minus r is 12 by 4. So, that is a factor of 3 times 1 by 3, that is 1, which means T r plus 1 is equal to T r, all right. when r is equal to 3. When r is equal to 4, T 5 is 11 by 5 times 1 by 3. So, 11 by 15, right, T 5 is 11 by 15 times T 6, sorry, T 5 is 11 by 15 times T 4, right, which means that T 4 should be regarded as the largest one. All right. Now, what if you had actually paid attention to the minus sign? What would have happened in that case? So, suppose you say that no, this minus sign means something to me, I want to take charge of the minus sign as well. In that case, what is going to happen? Your fraction is going to be r minus 15 by r plus 1 times 5x by 3, which is nothing but 1 by 3. Okay. And you are looking at a problem over here, because r minus 15 by r plus 1 is negative most of the time. Okay. So, it is almost always satisfying this relationship. Okay. So, you can't really go with T r plus 1 and T r anymore. The sign is alternating. All right. So, you should not worry about this negative one. Okay. Let us look at some other problems. So, this is something similar to what we had done in our last class. More practice. Okay. So, this is somewhat more complicated than the ones that we did in the last class, although this is the conceptually it is similar. So, find the term independent of x in this complicated expression. Now, notice the following: I have got a 1 over here, I have got an x and an x cube, which means 1 times the term independent of x will be independent of x. X times the term for 1 by x will be independent of x, and x cube times the term corresponding to 1 by x cube will be independent of x. So, you have to look at the expansion of this and 3 terms in the expansion of this. Which terms? X power 0, 1 by x and 1 by x cube. So, these are the 3 terms that you are looking for in this expansion, and then you are going to add those terms. You are going to add 1 times the first one, 1 times the second one, and 2 times the third one, and that will give you the overall picture. Okay. So, we basically need to look at just this expansion, evaluate x power 0, evaluate 1 by x, and evaluate 1 by x cube. Okay. Now, look at how the terms expand. So, you know that you have got a general term is n c r, in our case it is 9 c r times 3 x squared by 2 whole power 9 minus r times 1 by 3 x whole power r. Okay, this is the rth term. Okay. So, if you look at x in this, I have got x to the power 18 minus 2 r over here, and from here I have got x to the power r. Okay. which means that this is how the terms are going to be organized. So, I will start, if r is equal to 0, then I will start with x power 18, r is equal to 1, I will get x power 15, then x power 12, 9, 6, 3, 0, minus 3 and so on. So, what all are you looking for? You are looking for 0, minus 1 and minus 3. Now, minus 1 is never going to come. This term is just absent, right. So, it is uninteresting. I mean, you are not going to arrive at x power minus 1 at all in this expansion. You will come to x power 0 and you will come to x power minus 3. When will you come to x power 0? When r is equal to 6, all right. And when will you get x power minus 3? When r is equal to 7. Okay. So, what you are now looking at is the 6th and 7th term of this expansion. So, the 6th term is 9 C 6 times 3 x squared by 2 whole cube times minus 1 by 3 x whole power 6. This is the r equal to 6 term, and r equal to 7 term is 9 C 7 3 x squared by 2 whole squared and minus 1 by 3 x whole power 7. So, these are the two terms, and then what are you going to do? You are going to multiply the first one by a 1 and the second one by 2 x cube, and then you are going to add them, and that will be your term independent of x. Okay. Now, what is 9 C 6? 9 C 6 is factorial 9 by factorial 6, which is 9 into 8 into 7, by factorial 3, which is 3 into 2. Okay. And 9 C 7 is what? It is 9 into 8 by factorial 2, which is 2, and then 3 x squared by 2 whole cube will give you what? 3 cube, which is 27, x power 6, but we know x will all cancel out, we will just check, verify, by 2 cube, which is 8, times minus 1 whole power 6 is nothing but a plus 1. So, the minus is not really important in this particular term, times 1 by 3 power 6. What is 3 power 6? 3 cube is 27, 3 into 3 into 3. So, let us write it as 27 into 27 into x power 6, and clearly the x power 6 cancels out neatly. And the other one, I have got a 2 in front, x cube in front, 9 C 7, I have written out the expansion, and then 3 x squared. So, 3 squared, that is 9 x power 4 by 2 squared. So, that is 4, and then minus 1 whole power 7 is a minus, and then 3 to the power 7, that is 27 into 27 into 3 into x power 7, and the x power 7 is going to cancel out. Because by design we have picked the term independent of x, the two terms independent of x. All right. Now, you will have to do the arithmetic and work it out. 27 cancels out. This 9 cancels out with the 27 and you get a 3, right. 8 cancels out with 8. So, you get 7 divided by 18 for the first one. And for the second one, I have got 4, 2 cancelling out with 8, 9 and 9 cancelling out with 27 and 3, and that is it. Okay. So, all I have is 2 and 27. And this is a reasonable fraction to work out, right. Is it reasonable? Yeah, it is quite okay. I mean, you just go to 54, right. So, that is how it is. So, we have worked out the term independent of x in this massive complicated expression. Okay. So, let us try another one. So, this is given to you and then you are told that this f of x also happens to be equal to a 0 plus a 1 into 1 plus x plus a 2 into 1 plus x the whole squared plus a 3 into 1 plus x the whole cube plus dot 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 all the way till a sub 17 1 plus x whole to the power 17, and that will give you the x power 17 term. Okay. So, you are told that a 0, a 1, a 2, a 3, a 17 are such that f of x is equal to this and the same thing is equal to this complicated expression. Now, you are told, you are asked what is a 2. Okay. How will you do this? How will you work this out? So, let us make a few observations. If you look at the 1 over here, then the 1 equates to a 0 plus a 1 plus a 2 plus a 3 plus all the way till a 17. Okay. And that is just the one, the first term. Let us now look at the second term. The second term is minus x. So, who all are producing a minus x, who all are giving you the x term? So, a 0 is not. I have got a 1 times x, right, and then I have got 2 a 2 times x, 3 a 3 times x all the way till 17 a 17 times x. Okay. And then you can cancel out the x from both sides, you will get a 1 plus 2 a 2 plus 3 a 3 all the way till 17 a 17 is equal to minus 1. Okay. Is that going to help? Let us see, right. Maybe what you can do is, okay, let's do the next one. So, we have done this already. What about x squared? A0 is not going to give me an x squared, A1 times 1 plus x, there is no x squared in this, but A2 times x squared, and then A3 will give me a right 3C2 times x squared, 3C2 is nothing but 3, and then A4 will also give me an x squared. Sorry, okay. Now let us see what we have over here. So, in other words, I could have written this as 1 is equal to 7 A0 plus 1 C0 times A1 plus 2 C0 times A2. 1 is, if you choose nothing, you get only one way of choosing nothing. Okay. Here A1 plus 2 is really 2 C1, 3 is really 3 C1, and so on. And likewise A2 you are in front of A2 you have got 2 C2, which is a 1, and then 3 C2, 4 C2, 5 C2, 17 C2. Okay. How are these terms moving? So, what is the difference between 3 C2 and 4 C2, for example? 3 C2 is factorial 3 by factorial 2 into factorial 1. 4 C2 is factorial 4 by factorial 2 factorial 2. 5 C2 is factorial 5 factorial 2 factorial 3, and so on. Okay. What does that mean? That means that if you look at this term and if you look at this term, what is the ratio? This has increased by a factor of 4, the numerator, and the denominator has increased by a factor of 2. Then over here you have increased by a factor of 5, the denominator has increased by a factor of 3. Okay. The next term you are going to increase by a factor of 6, decrease by a factor of 4, and so on. All right. So, let us write it out slightly differently. So, these are just observations. I have still not done the problem. This may or may not be relevant to the problem. A2 3C2 is factorial 3 by factorial 3 by factorial 2, which is just 3, right. And 4C2 is 4 by 2 times that. This is what I have. And of course, you can construct many more relationships for x cube, x power 4 and so on and so forth. The question was, what is A 2? Now, you have got 17 unknowns, 17 equations, you should, I mean, one should be able to solve it, but it is not so straightforward. Okay? Can't really do it that way. What will you do? So, this is where you need lateral thinking, all right. So, unlike your mathematics till class 10, your mathematics till class 10 had many different parts. You had geometry, you had algebra, you had arithmetic, you had mensuration, you had trigonometry, right. All of these different parts did not talk to each other. If you are good at geometry, it does not mean that you have to be good at arithmetic. If you are good at arithmetic, it does not mean that you need to be good at algebra, and so on and so forth. So, they were independent, somewhat independent of each other, they were completely different sectors. A problem from mensuration could not be done with, need not be done with geometry or algebra, right, in your class 10 mathematics. In your class 12 mathematics, unfortunately, this compartmentalization of maths is no longer valid, right. You have to be able to be agile, you have to bring in concepts from complex numbers, throw them at binomial. You have to be able to bring in your calculus, throw it at binomial. You should be able to use your binomial in calculus, you should be able to use your coordinate geometry in your calculus, and I mean anything goes with anything, right. Coordinate geometry will go with trigonometry, suddenly you will find trigonometry inside the binomial theorem, it is a mess, right. You should be able to pick up concepts from here and there and apply it elsewhere. So, it is all a mix up. Okay. So, what we are going to do over here in this particular problem is we are going to use a little calculus. Let us try, right. Let us try using a little bit of calculus. Now, f of x is a polynomial in x. Okay. What do you think is df by dx? I am assuming you know calculus. Df by dx is nothing but minus 1 plus 2x minus 3x squared plus 16x power 15 minus 17 x power 16 and so on, and this happens to be equal to, you can do the same thing, you can do a derivative of this as well. How do you do a derivative of this? Derivative of a 0 is nothing, derivative of a 1 times 1 plus x is a 1 times the derivative of 1 plus x, which is 1, plus derivative of a 2 plus a 2 times 1 plus x squared is a 2 a 2 times 1 plus x times derivative of 1 plus x, which is 1, and so on. You get the picture. All right. And now things have suddenly started to look like our sequences above, haven't they? Now equate the one term. So, if you look at the one term, now you have got minus 1 is equal to a 1 plus 2 a 2 plus 3 a 3 plus 4 a 4 plus 17 a 17. Okay. So, you have got this relationship already. Have you? You have. Okay. Can do a second derivative. So, there is a shortcut, you write this as f prime, right. You can write this as f double prime. So, this is the derivative of the first one, and this is we need to do the derivative of the next term as well. So, the first term, the first equality, this f prime is equal to minus 1 plus 2 x etcetera. This gave me a derivative which is so much, okay. And then I have to work with the second one, and that what is the derivative of that. So, the derivative of that, you need to see it. I can see it, but for you this was off screen. So, let us try it this way. So, the derivative of, you see what I am doing, I am going to do a derivative of this line. Two a2 times the derivative of 1 plus x is 1. Three a3 times 2 times 1 plus x plus 4 a4 times 3 into 1 plus x whole squared. All the way till 17 a 17 times 16 into 1 plus x whole power 15. All right. So, we have done some derivatives over here. We have done the first derivative, we have done the second derivative. Now, if in the derivative equation you plug in x equal to 0, suppose you plug in x equal to 0, then all of this goes away, right. All of these terms disappear, you are left with minus 1, which will be equal to a 1 plus 2 a 2 plus 3 a 3 plus 4 a 4 plus dot 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 plus 17 a 17, and guess what, that happens to be this equation. Okay. If on the other hand you had the second derivative and you again plug in x equal to 0, then you start with 2, the rest of the terms are all 0, 2 is equal to 2 a 2 plus 6 a 3. Okay, we did not really, did we have it? Yeah, 2 x squared was equal to 2 a 2 plus 6 a 3, right, plus 12 a 4 plus dot 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 17 into 16 a 17. Okay. So, we have done it slightly differently. All right. Now, again coming back to my question was what is A2? So, I have developed 3 relationships so far. These are my 3 relationships. In fact, what I did was I had 2 x squared over here and 2 A2, 6 A3, 12 A4, 4 into 5, right. All of these will cancel out, you will get 16 into 17. A17. Okay. So, our relationship is this, that so this is one relationship. A second relationship that I had was minus 1 is equal to A1 plus 2 A2 plus 3 A3 plus 4 A4 okay. And a third relationship was 1 is equal to A0 plus A1 plus A2 okay. So, these are my 3 relationships. You can build more relationships if you want to. All right. How will you solve them? Can you eliminate anything? Can you, for example, eliminate between these last 2 equations, the second and third relationships, can you eliminate A1 to A17? Is it possible? Well, if you take the last relationship and subtract out the second relationship, A1 does get eliminated. Okay. You can eliminate A1 out if you subtract one from the other, right. If you subtract between the first 2, right, if you take the first relationship and the second relationship, then you can subtract one from the other and you can get rid of A2 and you will be left with A1, A3, A4 and so on. The other thing to observe is that the number of terms in each of these relationships is decreasing, right. The first relationship had all 18 terms, next one has 17 terms, the next one has 16, right. If you write more relationships, you will get lesser and lesser and lesser terms, right. The 17th relationship will have only one term. Okay. So, that is also something to observe. Now, what can you do to simplify things? So, do you want to first find out the 17th relationship, then look at the 16th one, then look at the 15th one and so on and so forth, come backwards? That would be one way of doing things. Is there a more elegant solution to this? So, let us stop here. This basically has been a problem solving class, and we have been looking at a variety of problems. Unfortunately, this problem is still not complete. We are going to keep working on this problem, but what we have done so far is we have used the binomial theorem. We have kept applying the binomial theorem. We have kept getting comfortable with the binomial theorem, and we have developed some relationships. We have also thrown in some other things that we know from elsewhere, for example, from calculus, and we have developed on the binomial expansion and so on and so forth. So, we are going to continue with this particular problem in the next lecture, and hope to see you soon. Thank you.